GenuinelyGwyn. So this week, nothing too exciting happened. I'm really sorry I didn't get a video out last week. I tried to, I filmed it and I edited it and everything, but then I had a problem with, the editor. Obviously, anyway, I'm really sorry about that. Let's see, I had a science test over energy. If you guys are ever learning about energy in science class or, just in general, it's a good thing to know. I wanted to help you guys out a little bit. So, let's get down to business. The first thing here that you need to understand is that the two main types of energy go hand in hand. Number one is potential energy, the first that we'll discuss. Come on, kids, hop on the school bus.
Potential energy, or in other words stored, is divided into two categories that were taught on the whiteboard. Elastic potential can be stretched or compressed. Like a rubber band, you got that down? Heck yes! Now let's move on to our other type of potential. Gravitational potential energy is think of a mug on a table. This type of energy has to do with the height of an object. Because gravity is acting on the mug, GBE is in effect.
That's it. I'm so proud of you. We're done with number one. But don't you worry, there's lots more to be done. Next up, what we're going to talk about is kinetic energy. Let's see what there's to find. This is energy in motion. Better hurry up or we'll leave you behind. Mass and velocity are the important factors here. It's what kinetic energy depends on. Now, are we clear? Number category 6, electromagnetic, nuclear, thermal, electrical, chemical, mechanical. Or is that too quick? Fine. Okay, we can break it down. Let's start with mechanical energy now. Mechanical energy has to do with motion, position, and shape. Now you gotta do some math. There's no way to escape. To find the grand total of your mechanical energy, add the total kinetic and potential. See? So basically mechanical is anything moving. From a ball being thrown to your grandma grooving. Thermal energy is what we'll tackle next. It's pretty straightforward, but there might be a test. In essence, thermal energy has to do with particles. And when I say particles, I'm talking atoms or molecules. Like a pot full of boiling water, those particles are moving fast. So in conclusion, is thermal energy the heat of something? I wonder you might be asked. No, it's not. Thermal energy has to do with particles on a thing. I hope you're paying attention because an F on that test would really sting.
I'll give you a break. Picture yourself on the beaches of Hawaii. I bet you can see the waves without even trying. This next type of energy is called electromagnetic. It moves in waves too, but I'll have to break your aesthetic. We're talking about the waves that we can't see, such as ultraviolet, or as we say, UV. You'll also find electromagnetic energy in microwaves, as well as whatever else uses waves, such as an X-ray. Electromagnetic energy has some unique properties. It combines those of electrical and magnetic. Quite the philosophy. Nah, philosophy isn't quite the right word, but we're learning about science, not English, so you get your eyes back on the nerd. I told you that electromagnetic is related to electrical. Electrical energy is nothing too terrible. It has to do with the electrical charges of an atom. You know how you see lightning strike and you think, it surely must be random. Well, it isn't. It's electrical energy being transferred. They're simpler examples, though. I give you my word.
Take, for instance, the lovely little light on which Edison worked with all his might. You see, good old Tom knew what he could do. Harnessing electrical energy, a constant source of light, was something he could pursue. Next up, nuclear, but don't worry, it isn't scary. It's energy stored in the nucleus, which is very small, very. There are two big types of nuclear energy. One is fusion. It's chemical reactions happening in the sun, not an optical illusion. Now, there's also nuclear fission. It has a very important job to do. Create electricity and won't stop on the mission. Now, I regret to inform you that this lesson is almost done. I don't want to leave. I've had so much fun. Fortunately for us, there's one last category. Chemical energy is pretty self-explanatory. See, it's energy stored in chemical bonds. I know it's no surprise without even seeing your response. But you see, it's just super important. It's my number one. Plants eat using chemical energy that they convert from the sun. When we eat and bonds break, we get chemical energy from the food, and when we use a candle to light a match and set the mood. Now here's where it gets a little confusing. Let's take a look at batteries. What kind of energy are they using? Now calm down. I'll try to explain. I know it gets messy, but please don't go insane. I know that all this info has you feeling smothered, but I want you to know when energy is changed from one type to another. We call it an energy transformation, and energy is never lost or gained thanks to the law of conservation. Well, there it is, all you need to know. I hope that you feel that this lesson was thorough. Energy can feel kind of complicated, but now you've been wholly and completely educated.